Good evening, Sanya. Good evening. Good evening, Yash. Hello, beta. How many are joined? There are six, but they have not given their attendance. Good evening, Nikhil. Good evening, Priyansh. Good evening, Sanya. Good evening, Divyansh. So today we are going to start with the models of the atom, right? A very important part of this chapter where we will study after the discovery of electron, proton, and many scientists they have given their models, and today we are going to study the models of an model of an atom. So let's start. So, model of the atom, particle model of matter. What? All matter is composed of. We have everybody is knowing that matter is composed of what? Tiny particles, known as atoms, right? And the combination of the types of particle in a substance determines what kind of matter is it. Okay, whether it's a metal, non-metal, metalloid, depends what kind of atoms are present inside the matter. If you want to decide the nature of the matter, depends upon what kind of the matter, what kind of atoms are present in the matter. I hope my voice is coming. Then initially in 500 BC, how these models regarding that atoms have developed. In 500 BC, Democritus inferred that all matter is composed of small indestructible particles. He named atomos. What was the name given by? Good evening, Abhishek. What was the name given by Democritus? Atomos, right? He thought that there was an indefinite number of them and that atoms differed in their size, shape, and weight. He also thought that the different substances were made up of different kinds of atom. So it means who has given us initial theory about the atoms. Initially nobody was knowing about the atoms. So Democritus in the 500 BC told us that all matter is composed of small indestructible particles. What was the initial name was given? That was atomos by him, right? He thought that there was an indefinite number of atoms, right? And then atom differed in their size, shape, weight, right? And he also thought that the different substances were made up of different kind of atoms, right? It means matter doesn't, every kind of matter will not have a similar kind of atoms. They will have different kind of atoms, right? So then who came? Then on 400 BC in Aristotle did not believe in atom. He thought that all matter was a composed of combination of the four element air, fire, water and earth. And his model was of course accepted by the next 2000 years, right? Then John Dalton came. Then after experimenting with the gases, especially hydrogen gas, methane gas, oxygen gas, and Dalton rediscovered the particle theory of matter. And we know that Dalton was able to infer four things about matter, that atom of one element have masses that are different from the atoms of the other element. It means atom of the similar atom will be having similar masses as per him, right? And later on we have proved that atoms of the same elements may differ in their atomic masses in case of isotopes. We know that in case of isotopes, atoms of the same element may have different atomic masses. They may be having same atomic number, atom of the same element, but they can have different atomic masses. So atoms, as per him, as per Dalton, atoms of one element have masses that are different from atoms of the other elements. Then atoms of the same elements are identical in all aspects as per him, but we have proved him wrong after the discovery of isotopes. Then he said that an atom of one element cannot be changed into an atom of another element. This point is correct, because we can't convert one matter to another. Means we can't convert nitrogen to oxygen atom or oxygen to nitrogen atom. And he is correct. He was correct. Then atoms of different element can be combined or rearranged to form new substances. Yes, this is also correct. And based on this point, we know there is a law of constant proportion, law of definite proportion was given by J.L. Proust, right? Then, like Democritus, Dalton thought an atom was a tiny irreducible sphere that could not be destroyed. Means as per him it was indestructible. But after the discovery of electron by discharge tube by the J.J. Thomson, it was proved that atom is not indivisible. It can subdivide it into three subatomic particles: electron, proton and neutron. Then J.J. Thomson, we have already understood, in 1819, J.J. Thomson, excited by the discovery of X-rays. Now, we know there are three types of rays: X-rays, right? So, excited by the discovery of X-rays by a couple of years earlier, Thomson played around the radioactive waves and discovered that atoms have electrical charges. Not only that, he discovered that those charges comes from small particles which make up the part of the atom. He called particles electron, right? Now, after that, Thompson model of an atom came, right? Thomson thought that the atoms consisted of positively charged main body attached to, right? These were the negatively charged electron. Plum pudding model, you must have heard the name. So now it has been well established that the atom contains negatively charged particles, that is electron. After the discovery of electron, and to maintain the electrical neutrality, the positive charges were also present within that. And you know, the Goldstein has proved the discovery of protons, right? And yesterday only we have studied the discovery of protons, right? The question arises how these negative and positive charges are distributed within atom, right? So J.J. Thomson in 1904 proposed that atom was a sphere of positive electricity in which were embedded number of electrons sufficient to neutralize the positive charge, and this may be compared with the watermelon in a seeds, like in which seeds are embedded, or you can say within a pudding containing current, or you can say the dry fruits, right? And this model of atom is known as Thompson model, and however it could not explain the result of a scattering experiment which was conducted by Rutherford. Hence it was rejected, because Rutherford has conducted his scattering experiment and it was carried in 1911, and because he could this model could not explain the conclusion of Rutherford experiment, and that's why it was rejected by various early scientists, right? And then you know that then who came into existence? Understood or not understood, beta? You have to give me information that are you getting or not. If you have any doubt, Sanya, Nikhil, Divyansh, Abhishek, Vaibhav, Raj, if you have understood, please write ma'am understood. If you have not understood, please tell me. Okay, beta. So let's start very important model, that is Rutherford model of atom. Now, discovery of nucleus, who has discovered nucleus? Rutherford has discovered nucleus. Initially, nobody was knowing about nucleus, that there is some nucleus inside the atom, right? So, it was proved after the discovery of Rutherford experiment, right? So, Rutherford in 1911 performed some experiment in which he has bombarded a thin foil of a heavy metal like gold with a beam of fast moving alpha particles, and which were doubly charged helium atom. Do you know how helium atom can be? How helium atom can be formed? Do you know that? How helium atom can be formed? You know that yesterday only I told you how we can knock out the electron when very large amount of electricity will be applied, maybe more than 10,000 volt electric current will be applied. So what is going to happen? It is going to knock out the electron which are present inside the atom. Suppose helium atomic number is 2 and it must contain 2 electrons because its atomic number is 2. So 2 electrons were there. Now how we can knock out these 2 electrons? If you knock out these 2 electrons, so what is going to happen? We'll get helium 2 plus charge. It means it is doubly charged. So what he did in this experiment, which metal he has taken? He has taken a thin foil of a heavy metal, that is gold, right? And how he has bombarded? He has bombarded a thin foil of a heavy metal like gold with a beam of fast moving alpha particle. And what was the alpha particle means? Alpha particle means doubly charged helium ions, that is He2 plus, and each having 2 unit of positive charge. I told you, and helium 2 plus means what? If you remove 2 electron, 2 proton will be left behind. So what alpha particles were carrying? They were carrying doubly charged helium 2 plus ions, and which has a 2 units positive charge and 4 unit of mass, because helium mass is 4u. And yesterday only we have seen that protons and neutrons, they remain inside the nucleus and they make the mass of an atom. If I say how to calculate the mass number of any atom, that is P plus N. It means helium was carrying how much mass? Helium 2 plus charge ion carrying was how much mass? That is 2 plus 2 means 4, 4u, 2 proton and 2 neutron, right? So what was the charge? What was alpha particles were carrying? Doubly charged helium atoms, and each having 2 units of positive charge and 4 unit of mass. So when and which metal he took? He took gold foil, right? So he took a gold foil, which is a heavy metal, right? And then these were obtained from radium. Like if I say, what is the source of alpha particles and how he has got this alpha particle? But there should be some source. So these the alpha particle rays were obtained from the radium placed in the cavity of the black box. It was placed in the cavity of the black box, right? And then after that, so and the black box of what? Black box made up of lead and made into a fine beam with a slit. And he has done a very he wanted to that there should be a very fine beam. So he kept one slit inside the black box, which is made up of lead, right? So he observed the scattering of the alpha rays after hitting the foil by placing a circular zinc, right? You can see here, this is zinc, this is circular what? This is what actually? This is circular zinc sulfide screen around the metal foil. This is the metal foil, and this is blue one is what actually? This is the blue one is circular zinc sulfide screen around the metal foil. And whenever alpha particles strike the screen and there was a flash of light produced in that point of the screen. So it was actually fluorescent screen, right? And when the rays were hitting on the screen, and every time flash of light was produced at that point of screen, right? But if you remember the Thompson pudding model, that as per him the mass was evenly distributed. And what was the thought in the Rutherford's mind? That he said, I want to confirm Thompson pudding model, where positively charged means the atom is made up of what? As per Thomson, atom is made up of positively charged particles and it is scattered everywhere. It is a positive sphere. It means if he carries the helium 2 plus ions, and we know that opposite charges attract but same charges repel each other. So what was his expectation? That when I will bombard with alpha particles, since alpha particles are carrying helium 2 plus charge particles, so obviously when they hit with the positively charged particle, that is proton inside the atom, so they will come back, they will repel back. So but what was his observation after that? And the results were opposite, just opposite. Why? Because he observed something else in place of what he expected. He expected that every rays are bound to come back because of the force of repulsion, because alpha particles were carrying He2 plus ions And he said atom is made up of what? Positive sphere. It means positive charges are present everywhere, so they should always repel back. But what was the result of Rutherford experiment? It was just opposite, right? It was just opposite. Okay, so how he has started, I am repeating once again if you want to understand once again. As per him, what he did in 1911, he performed one experiment where he has bombarded a thin foil of heavy metal gold with a beam of fast moving alpha particles which are doubly charged, helium 2 plus, having 2 positive charge. And what was the mass? The mass was 4u. And when we know what is the source of this, we have already understood what is the source of this alpha particle helium 2 plus charges. That is what? Actually radium. And the radium was kept in the cavity of the box, which was made up of, or you can see the block of lead, and there was very fine slit, so that from that slit the rays should come, or the fine beam should come out, right? So after bombarding, what he observed, the scattering of the alpha particle hitting the foil. And I told you aluminium foil was covered by what? You can see this is a screen which is made up of zinc sulfide, right? And around the metal foil, so he has placed a movable, you can say this is a movable, we can rotate it, right? So he has kept he has placed a circular zinc sulfide screen around the metal foil, and whenever alpha particles was used to hit the screen, and there was a flash of light produced at the point of the screen. From this experiment, right, he has done twice, thrice, and many times. What was his observation? So from this experiment, following observations were made. Most of the alpha particles, that is 99.9%, pass through the foil without undergoing any deflection. But what was his expectation? He thought, because at the in the Thompson pudding model, it was told that the positive charges are spread everywhere. It is present everywhere. So what he thought, if I bombard alpha particle, they are bound to come back because of the force of repulsion. But the results were opposite, right? The first observation was what? The most of the alpha particle, that is 99%, pass through the foil without undergoing any deflection. But his expectation was that these rays are going to deflect, but there was no deflection. And then some alpha particles, second observation, some alpha particles were deflected through small angles and a few were deflected through the large angles, right? Understood or not understood? Yes, class? Understood, not understood? Understood, not understood, class? And what was the third observation? The third observation was very few, means only one in, it is written in the NCERT, only 1 in 12,000. So very few means only 1 in 12,000 rays were deflected back. It means they must have come across with something which was possibly charged. It means they were hitting protons at that point of time, right? And through an angle of greater than 90 degrees Celsius, 90 degree, right? So very few means only 1 in 12,000 were deflected back. So we can say there were three. So how many were there? So now he has given three observation. The first observation was most of the alpha particle, means most of the means what, 99.9% pass through the foil without undergoing any deflection, and some alpha particles were deflected, means some alpha particles were deflected through the small angles and few were deflected through the large angles. And then third observation, very few means 1 in 12,000 rays were deflected back, means they through an angle greater than 90 degree. And if what conclusion we can make from these observation? So there were three conclusion, or you can say four conclusion made from these observation. The first point I said that most of the alpha particle pass through the foil without undergoing any deflection means there must be sufficient empty space within atom, right? So atom is mostly empty space. So what this experiment has proved that the most of the space inside the atom is empty, and that's why though most of the rays means 99 point rays were able to go through that. So they can easily pass through that. It means there is nothing in their path. There is no hurdle in their path. So this point proves, but what the model plum pudding, what was the observation according to plum pudding model, that the positively charged particle are spread everywhere. But after the discovery of this, after this experiment, it was proved that no, the space inside the atom is empty. How we can say that? Because most of the rays, that is 99.9% rays, were easily passed through that, right? So easily passed through the foil without undergoing any deflection. This point proves that there must be sufficient empty space within the atom. It means we can say most of the atom is empty. Understood or not understood, class? Sanya? Now the second observation. The first observation we have understood when he said that the most of the alpha particles were easily passed through the foil without any deflection. This point proves that the most of the space inside the atom is empty. Now the second point. What was the second point? Since most of the alpha particles, it means since some alpha particles were deflected through small angles and few were making large angles. So alpha particles are positively charged particle. We know that, and these could be deflected only by some positively charged particle only present within the atom, right? So the alpha particle deflected through the small angles were those which passed close to the positive body, and the alpha particle deflected through the large angles were those which were passed very close to the positive body. Understood? So why they have made small angles and large angles? Because they must have come across through the some positively charged particles. It means they have experienced what? Force of repulsion. Because of that they have made small angles and large angles. So since some alpha particles were deflected through the small angle, or you can say few through the large angles, so why it was happening? Alpha particles are what? Positively charged particle, and these could be deflected only by some positively charged body present within the atom. It means they come across what? Proton present in the atom. And here alpha particles were carrying what? Helium 2 plus ion, and protons are also having positive charges repel each other. So the alpha particle deflected through small angles were those which were close to the positive body, and the alpha particle deflected through the large angles were those which pass very close to the positive body. Understood, class? Okay, now the third observation. He said very few alpha particles were deflected. Means one out of they have directly deflected back, right? So since some alpha particles are deflected back, it means they must have hit with something hard and dense. And that's why they have, suppose if we throw one ball on the wall, what is going to happen? It is going to come back. It means the ball, where we are throwing the wall is something hard and dense. It is going to reflect back to us. Likewise, when very few rays, what was his observation? Very few, only 1 in 12,000 were deflected back. So it means what? And through an angle of greater than 90 degree. So it means that they could be deflected back only when they strike heavier body inside the atom. You can take example of ball. When you hit the ball in the wall, ball will come back. It means we are hitting the ball to the very hard and dense. Likewise, when these rays were strike to the something hard and dense which is present inside the nucleus, which is present inside the atom, means that's what they have deflected back. Okay, so since some alpha particles are deflected back, and alpha particles are heavy particles, and these could be deflected only when they strike heavier body inside the atom. And we know what was, how you can make one more conclusion on that. It means this heavier body is actually what, right now we know it is a nucleus, because nucleus is present inside the atom, and it is present in a very small area of the atom. It means most of the space inside the atom is empty, and nucleus is concentrated in the center in a very very small place, right, in a very very small place. Since number of alpha particles deflected back is very very small, this shows, what was this, the further observation, since number of alpha particles deflected back is very very small, this shows that heavy body present in the atom must be occupying a very very small volume. So the small heavy positively charged body present within the atom was called nucleus, and that's why Rutherford is responsible for the discovery of nucleus, right? He discovered nucleus, right? Understood or not understood, class? So on the basis of result discussed, whatever results and how they have concluded these results, because based on the three observation, right, and then scattering alpha particle according to Rutherford model can be shown like that. So how we can, now you can easily imagine that helium was carrying what, 2 plus charge. When you see the helium atom is, there are two protons and two neutrons. We know the electron can be like this, proton is positively charged, neutron does not have charge, right? So what was his observation? Based on this experiment, he has given the nuclear model of the atom. So on the basis of scattering experiment, Rutherford put forward a model also known as Rutherford's nuclear model. The main point in the model will be what? We should know that atom consists of two parts. One is nucleus, right, which is centrally located, and the second is what, extra nuclear part. One is nucleus, another is extra nuclear part. Understood? So as per Rutherford experiment, we can conclude that the atom consists two part. One is the nucleus and the second is the empty part, right, that is the extra nuclear part. And nucleus is small, heavy, positively charged body present in the center of the atom. That's why the rays, when they hit back, they reflected back, right? When they hit, it means it is something which is very hard and dense. So can we say that mass is concentrated, the mass of the atom is concentrated in the center of the atom? Yes. And that's why they, when they hit, these rays when they hit, and since they were also having nucleus is, agar overall charge of the nucleus is what, when you see the overall charge of the nucleus is positive, because neutron does not have any charge. So it means the nucleus is positively charged, and the alpha particles were also carrying helium 2 plus signs. It means positive charge repel each other. And second thing, the rays were hit with something hard and dense. It means we can conclude that the mass of the atom is concentrated in the center of the nucleus. Understood? So nucleus is what? Nucleus is a small, heavy, positively charged body present in the center of the atom. And when we say the other part is what? The empty space, means extra nuclear part. Extra nuclear part means what? The space around the nucleus in which electrons are distributed. Understood, class? Electrons are distributed. So we can say that entire mass of the atom is concentrated in the nucleus, right? Since electrons have negligible mass, we know the electrons are negligible mass, and protons are having mass, neutrons are having mass, and we know that protons and neutrons always remain inside the nucleus. It means the entire mass of the atom is concentrated in the nucleus. Since electrons have negligible mass and the mass of the atom is mainly due to the proton, hence proton must be present in the nucleus. Hence protons must be present in the nucleus. And the presence of positively charged proton in the nucleus also accounts for positive charge on the nucleus. Just now I told you, nucleus is what? It is a positively charged. Why it is positively charged? Because of the protons present inside the nucleus. because neutron does not have any charges, right? They are neutral. They don't have any charge. They are neutral. So can we say that the nucleus is overall charge and the nucleus will be positive? Understood. So after the discovery of neutron, it was suggested that the mass of the atom is due to the protons and neutrons. Hence, nucleus contain protons and neutrons. So we can prove what does a nucleus contain? Since mass is because of what? The proton inside this, and the neutron does not they are always present in the nucleus. So after the discovery of neutron, it was suggested that the mass of the atom is due to protons, right, and neutrons, and hence nucleus contain protons and neutrons. To explain that electrons do not fall in the nucleus as a result of attraction, Rutherford suggested that electrons were not stationary, right? They were not stationary but were revolving around the nucleus in the certain circular orbits. As a result, centrifugal force comes into the play, which balances the force of attraction. Because this is the main drawback of the Rutherford model. You should pay attention in this point. This is very important point, where you can see that Rutherford suggested that electrons were not stationary but were revolving around the nucleus in the circular orbits, and as a result its centrifugal force come into the play, which balances the force of attraction. But do you think what is a drawback of Rutherford model? Do you think what is the drawback of Rutherford model? The drawback of Rutherford model could not explain the stability of the atom, because just now I said that he said that electrons are revolving around the nucleus, and that's why the force of repulsion, the force of attraction can be balanced. So Rutherford model, you can note down or you can understand this very nicely, because every time drawback of Rutherford model can be asked. So what could be the drawback of Rutherford model? Rutherford model could not explain the stability of the atom. This is because according to the Rutherford model, an atom consists of a small heavy particles charged nucleus in the center, and the electrons are revolving around it. But however, whenever a charged particle like electron is revolving around a central force like that of the nucleus, it loses energy continuously. Because if any charged particle move around another charged particle, they are going to radiate energy continuously in the form of radiation. It means one stage will come when these electrons are going to lose all of its energy, and it is going to fall inside the atom nucleus. So the atom nucleus is going to destroy it and matter is going to destroy it. But this is not happening actually. It means he could not explain the stability of the atom, because what was the thought behind this. He said that why he could not explain the stability of the atom. This is because according to Rutherford model, atom consists of small heavily positively charged nucleus in the center, and electrons are revolving around it. But whenever any charged particle like electron revolves around a nucleus, because nucleus is also positively charged, so one charged particle is revolving into the another charged particle, so it is going to radiate energy, because continuously it is revolving. Obviously, it is going to radiate energy in the form of radiation. So one stage will come where it is going to lose all of its energy, and it is going to fall inside the atom, and then obviously as a result nucleus inside the nucleus, and the nucleus is going to destroy, and as a result matter is going to destroy. But matter can never be destroyed, can never be, we know that. So thus the orbit of revolving electron will keep on becoming a smaller and smaller. If you must have seen that there is a diagram in the reference books, so that shows what? So if the orbit of revolving electron will keep on becoming smaller and smaller, if we come more closer, and then you can see the spiral path, right? If it comes more closer, ultimately electron should fall into the nucleus. In other words, atom should collapse. I told you atom will never collapse. Matter can neither be created nor be destroyed. So atom can never be destroyed. However, this actually does not happen at all. An atom is quite stable, we know that. Atom of all the elements are quite stable. They are not going to destroy, right? So we can say that Rutherford model could not explain the stability of the atom. Understood, class? Understood? In the next class we will study the Niels Bohr of atom, right? So if you have any doubt, you can ask. If you have understood, that's very nice, because this is very very important. In the next class I will draw the diagram, the Krita screen. I will show you how, right? So in the next class we will study, because only 5 minutes are left and I have next class also. Okay, so thank you very much. If you have any doubt, you can ask me, beta. Understood or not understood, beta? Yes, I am waiting for your answer. No doubt. Okay, beta. I hope everybody has understood Rutherford model. I will explain this model once again through the diagrams also. Okay, good, good, good. Wonderful. So next class I am going to ask you the observation, and based on the observation what were the conclusions were made. So can we say that Rutherford has discovered nucleus? When Rutherford has nucleus, okay, beta. So when Rutherford has discovered nucleus, we then only we come to know that where actually protons are, because as per Thompson pudding model, he said that protons are everywhere, right? It means it is a atom is made up of positive sphere and electrons are embedded in it. But as per as per the Rutherford model of atom, we have seen that protons are not everywhere. They are concentrated in the nucleus. They are located inside the nucleus, and nucleus is concentrated in the center of the atom. And it means the atom is having two parts. One is the extra nuclear part and another is nuclear part, right? And after the discovery of neutron, who has discovered neutron? James Chadwick. That we will study. Okay, so thank you very much. In the next class we'll study Niels Bohr. Okay, so I'm going to end my class. Thank you.